so slowly that we'll consider it in the liquid phase, right? And then if I continue to decrease this temperature, the molecules will move even slower to the point where they're only really vibrating, and that's what we call the solid phase. So temperature is directly proportional to the average kinetic energy of a gas. Okay, those are the 5 assumptions we're going to make for kinetic molecular theory. Based on those assumptions, we have the ideal gas law. And I want everyone to know the formula of the ideal gas law. If I can ever stop coughing. Most of you, I think, already have it memorized, but it's just PV equals nRT. And we remember that P represents pressure. And the units that we'll use for pressure are ATM, atmosphere, which we talked about are basically just this arbitrary, random, we're going to say that normal atmospheric pressure is 1 ATM, for example. V is volume. Excuse me. And the units for volume are liters. N represents moles, right? And we already know moles. And then R, which we didn't really get a chance to talk about in class because I kept telling you, just don't worry about it, it's a constant. A constant means you memorize it, you stick it in the equation, you plug and chug. We're not going to use R except that you need to memorize it, and when you're using this equation, you need to plug it in. So the SI unit for, actually I shouldn't say that, excuse me, the value for this constant R is 0.0821. I don't know why I can't write upside down right now. I usually do it really well. Pretend that looks like a 2. 0.0821 liters times ATM divided by moles times Kelvin. And you'll see why this makes sense once we actually start using it in an equation. And of course the temperature is in Kelvin. Now what we talked about in class, we focused most on Charle's law. We focused on Boyle's law and on Avogadro's law. Okay. So, if I'm going to start with Charle's law, remember that if you haven't memorized these yet, it's not a matter of just like memorizing rote memory like Huffle's Blossom. It's really, if you understand it, then there's nothing to memorize. Every single law is related to, we're concerned with the volume of the gas, okay? So we have this ideal gas law, which is really an equation. It's just showing the relationship among these 4 variables: pressure, volume, moles, and temperature. Those 4 variables are how we basically define the situation of a gas, okay? And then there are mathematical relationships here that we need to understand. So Charle's law, we can see it just by looking at the equation. So we can see, for example, that this is volume, and when volume is on one side of the equation and temperature, which is what Charles is concerned with, is on the other side of the equation, that means that these two are directly proportional. So Charles' law is basically just stating that volume is directly proportional to temperature, meaning we use the example, I think, of soda. Like if you put a can of soda in the hot sun, soda has carbon dioxide gas forced into it. So if you were to keep soda out in the sun, which you guys all know because you live in Saudi Arabia, then when you open it, it's gonna push out and try to, it'll overflow over the can. Because the higher you raise the temperature, that gas desires to increase its volume. So that's the relationship that Charles talked about. And the little way we were remembering Charles was just to think of a can of soda. And then when we were talking in class about Boyle's law, we used the example, we kind of cheated because the example we used doesn't have to do with gas, but it's still the same idea. I mean, we used the example of a blood vessel. And we were talking about a medical term called atherosclerosis, which is just basically like when someone, people with really bad diets can actually get this yucky buildup around their blood vessels, which will decrease the volume of their blood vessel, right? And then when they decrease the volume of their blood vessel, when volume is decreased, what winds up happening is they wind up having to go to the doctor because they have high blood pressure. So you can either intuitively know that Boyle's law is talking about an inverse relationship, saying that volume is inversely proportional to pressure. Either intuitively, when you think of something like a blood vessel, you know that the smaller that blood vessel gets, the higher the pressure is, or you can look at the equation. And when you look at this equation, you see that pressure and volume are on the same side of the equal sign, right? So if I wanted to actually bump this P over to the other side, what I would have to do is I'd have to divide by P. So now I have volume is proportional to 1 divided by P. This is an inversely proportional relationship. So you absolutely must know that Boyle's law deals with the volume and pressure of a gas and the relationship between the two, which is inversely proportional. When one goes up, the other goes down. When one goes down, the other goes up. And then lastly, we have Avogadro's law, which I think should be the easiest for you guys to remember just because it has to do with the moles, N. And, you know, that's what Avogadro discovered. And again, volume and the number of moles are directly proportional. That's what Avogadro said. So if I were to, for example, increase the number of moles in a gas, then it would wind up, remember that little thing we said, the little, like, we had a container in class and it had rocks at the bottom. We were going to pretend those rocks were gaseous molecules, and there was a container at the top. And we said that if we were to increase the number of moles, then it would wind up pushing at the volume of the container. So you increase the number of moles, and it's going to want to increase the volume of the container. And that's all Avogadro's law says. So again, we have Charles' law, Boyle's law, Avogadro's law. We talked about ways to remember all of them, and then we talked about looking at this equation, and even if worst case scenario you forget, you still should be able to understand the relationship just by looking at this equation mathematically. You should be able to to identify what is proportional, what is inversely proportional. So for example, if I didn't ask you anything about Charles' law or Boyle's law or Avogadro's law, but I was interested in the relationship between temperature and pressure, is temperature and pressure, are they directly proportional or are they inversely proportional? If you look at the equation, just by virtue of the fact that they're on opposite sides, you know that they are directly proportional. If one increases, then the other should increase. So that's the relationship between the two. So now that we covered that, we're just going to do one example, and I'm going to stop the video because I feel like I'm going to die. I'm coughing too much.